Welcome back. Let's continue on. Again, our key here is that if we are given a polynomial of the form x squared plus bx plus c, we attempt to find two factors of the constant term c whose sum is equal to b, even if it looks a bit more complicated. So let's consider this one. We've got x squared plus 19x minus 66. But remember, because we've got that negative coefficient, our factors are going to have to be one positive and one negative. So we need factors of negative 66. Factors of negative 66 whose sum is going to be positive 19. Well, we're going to have to think about this one. Negative 66. What can we do? Negative 66 is the same thing as we could say 11 times 6. Does that work? Well, maybe, maybe not. Let's see. We would have to have one negative, one positive, so we could think negative 11 plus 6. Well, negative 11 plus 6 won't work, right? Because we know that a negative 11 added to positive 6 is going to give us negative 5. That's no good, right? And of course, positive 11 and negative 6 won't work either because that's going to give us positive 5. But that's not our middle term, so we can't use that. Let's see, what else could we do? Well, how about negative 22 and positive 3? Well, negative 22 times 3 is certainly negative 66. Let's see how that one works out. If we take a negative 22 and add 3, we get negative 19. Well, we need positive 19, so we're going to have to change our signs here and say, how about positive 22 added to negative 3? Well, there you go. That is positive 19. And so that's our pair right there, 22 and 3. And as a matter of fact, it has to be not negative 22 and positive 3, but in fact 22 and negative 3. So when we write up our binomial factors, our both binomial factors here, we'll start with x, because x times x gives us x squared. Negative 66, well, that means we're going to have to take positive 22 and multiply it by negative 3. Negative 3, so that's 6, my mind went off here, minus 3, right, to get negative 66. And of course, you can check by looking at those two middle terms from your FOIL, right? If you work with your two inner terms, we'd have plus 22x. And if we looked at our two outer terms right here, we would end up with minus 3x, and we know that from our previous discussion, negative 22x minus 3x is positive 19x, which is the middle term, and so we're all set. Now, I would make a quick note right here. A polynomial that cannot be factored into integer coefficients is said to be prime or non-factorable over the integers. We're always interested in factoring over the integers. You'll notice that in each of our examples so far, we've had factors that contain only integer numbers, only integers as the coefficients. So in this case, if we are not able to find integer coefficients, we say it's not factorable over the integers. We sometimes call that prime. It does not mean that polynomials cannot be factored otherwise. For example, x squared plus 15x minus 2/15 is factorable as x minus 1/3 and x plus 2/5. It's a lot more difficult to find this, so we would say that it's non-factorable over the integers, to be very specific. Not that it's not factorable, just not factorable over the integers. So when we're looking for our polynomials, that's one of the things that we're looking for. Okay. Oh, wait, what's that question? How do I know those are the factors? Well, let's do a quick check. How do I know this would work out? Well, all right, let's try a FOIL here if we can. All right, by our FOIL method, first we would multiply x times x and we'd get x squared, so we're good there. Our outer terms, well, x times positive 2/5, so that's plus 2/5 x. 2/5 x, yeah, see, right, okay, so how about our inner terms? Negative 1/3 x. Looks like we're going to have a bit of fraction action here to deal with. And our last terms, negative 1/3 and 2/5. Last negative 2/15, right? Don't forget when you're multiplying two fractions, you're taking the numerator times the numerator and the denominator times the denominator. So 1/3 times 2/5 is going to be 1 times 2, which is 2, 3 times 5, 15. All right. Of course, we have to add our two middle terms right here. That requires a common denominator. Well, what's the common denominator? Of course, 15, right? So x squared plus, let's see, to get a common denominator, we multiply 2 times 3 to get 6 over 5 times 3, 15 to get x. We're going to take 2 times 1 over 2 times 3, 5 times 1 times 5 times 3, we're going to get 15 in the denominator. Remember, we want our common denominator to be 15. So that is 5/15 x minus 2/15. And if we take positive 6/15 and subtract 5/15 x, we're going to get 1/15. So x squared plus 1/15 x. 1/15 x minus 2/15 is our answer. And so it does work out. See, it is factorable, just not over the integers, right? So be very careful. We're going to concentrate on only integers for now. More in the next video.